I'm feeling a little generous, so I thought I would work out problem 2 as well, just to help you out, since I am not feeling my best. So here's problem number 2. We want the velocity of the object at 2 seconds. So let's be really clear. This is a flat line. And so what that tells us is that the velocity is going to be 0 meters per second. Now we want the displacement of the object over 10 seconds. So you notice right here, we're at 20. Remember, you look at the position mark. So what we have is that the final position is 20, having started at 50. So that means 20 minus 50 is negative 30. Again, if you want to know where I'm getting those numbers from, it's right here on this vertical, this up and down axis. Now we want the distance the object traveled. So from 0 to 4, we're going 0 meters, we're not moving. Yes, we're at 50, but we never move from there for the first 4 seconds. And then from 4 to 6 seconds, we go back from 50 to 0. And then from 6 to 10, we go from 0 to 20 when we actually look on the vertical axis here. And so our total distance is going to be 0 plus 50 plus 20, which ends up being 70 meters. Next, we want the average velocity of the object over 10 seconds. That's going to be the displacement over the time, just as it was before. So that'll be negative 30 over 10, and that's going to be negative 3 meters per second. Next, the average speed is going to be the distance over the time. That'll be 70 over 10, so that'll be 7 meters per second. Lastly, in part F, we're going to go ahead and plot the velocity as a function of time in the space below. So for the first 4 seconds, our velocity is 0. Next, here, let's look at the rise over the run. We go from 50 to 0, so this is 6, 0. And we're actually at 4, 50 when we look at our coordinates. So we're going to get our rise over run that way for the first part, from 4 to 6. So from 4 to 6, that's going to be 0 minus 50 over 6 minus 4. And that's going to give us negative 25 meters per second. So we can actually get that right here. And then for the last part, we're going forward again. We go from 6, 0 to 10, 20. So from 6 to 10, we'll use that rise over run. That's going to be 20 minus 6 over 10 minus, 20 minus 0 over 10 minus 6. So that's going to be 20 over 4, which is going to be 5 meters per second. So we'll plot that right here. And that's problem number 2.